Okay, fine.
After
Thanks.
TRC, DRC, I will quickly go through your diagram. So if you have any doubt in that, you can ask. Okay. Procedural query language here. Basically, yes, anyone? Yeah. Okay. No issue. So what is non-procedural query language here means? Like this TRC query will only give us the find out, right? What data and how to get that data, there is no information about that, right? So it will give us the only information about what data we have to find out. So this TRC and DRC, this tuple relation calculus and domain relation calculus are non-procedural query language. So it will give us only information about what data we have to find out, right? So how to get that data, there is no information about that, right? And domain and relational algebra is a procedural language, right? It is a procedural language. So it will give us the information about what data we have to find out and how to get that data, right? So procedural will consist of what and how, and non-procedural query language will consider only what data we have to find out. Okay, that is simple differentiation between procedural query language and non-procedural query language. Okay, now let us discuss about the TRC part first. So this is a general representation of TRC. This is tuple T, and this is the predicate, right? So predicate, like it can be a condition, like based on this condition. If this predicate is true, so based on this condition, it will fetch that particular tuple T, right? So it can have conditions logically combined with or operator, and not operator, like, and it can also consist of quantifiers like there exist and so on. Okay. There is some background noises there. Yeah. Okay. Fine. Yeah. So how to read this particular TRC query now? So for a tuple P, there exists S which belongs to student. So student is a relation here, right? So there exists S which belongs to student such that S dot CGPA means S belongs to student, right? So S dot CGPA should be greater than 8. So this is our required condition. Okay. And whatever we have to find out, we have to specify like this, like P dot name equals to S dot name. Means I want to fetch a name from the student table, right? And for a tuple P, so I have to specify like this P dot name equals to S dot S name. So S name in the student's name, okay, table. And similarly here, I also want to find out age of the student. So we have to specify P dot age equals to S dot age. So it will return the name and age of a student with CGPA above 8. So this is general representation of TRC. There is one more form. We can write this TRC query. Okay, so that we'll discuss with the help of an example. Yeah, so first we'll discuss about DRC, right? So tuple relation calculus will work on the tuples, right? And this domain relation calculus will work on this domain of this particular attribute, right? So the general way of writing the DRC query is like this. These are the domain variables, and we have to mention this domain variable in the same order that we have in the table, like attribute order here, name, age, marks, subject. Okay, and these are the predicates. So based on this condition, if it is true, it will fetch that particular domain variables, right? Tuples. So here simply representation at one of the example, like how to read this TRC query. So here A comma B. So what is A comma B here? So we don't know what is A comma B here unless we see this, right? So A comma B comma C belongs to student. Now this should be in the same particular order as given in the relation. That is, A stand for name, B stand for age, C stand for marks, and D stand for subject. So A belong to name, B belong to age, C belong to marks, and D belong to subject, and which belongs to particular table name, that is student. Okay. And now there is one condition, that is C greater than 75. C means marks. So marks greater than 75. And there is one more thing, like there exists A, B, C, D. So it is not compulsory that we have to mention like this. We can also write it as there exists A, there exists B, there exists C, there exists D, or we can just write it there exists A comma B comma C comma D. Okay, and here AB is A comma B means what we have to find out. So here A means name and age. So it will return the name and age of student having marks above 75. So this is a required condition, that is C greater than 75. Okay, but you have to note one thing, that you have to mention the domain variable in the same order as given in the table, right? So here you can see in this query, I am just using the variable C. Yeah, so I am just using this variable C. So even if I skip this A, B, and D part, I can write just there exists C and then start with this A, comma B, comma C, comma D. Still it is fine, okay? But it is always better to write all the domain variables. In some of the reference book, they will only use this there exists C because they are only using this C variable right here. So the difference notation using the difference reference book. So for this, we are only following our reference book, that is Silver Sash and Korth. And second reference book you can follow, that is DBMS by Raghu Ramakrishna. Right. So these are the only two reference book that you just follow for this particular topic. Sorry, noise is coming. Is this from my side? Or? Okay, thank you. Okay, so any doubt in this DRC part, like how to represent DRC?
Sir, in the second part where it's written there exists ABCD. So this ABCD should be the same, should match, or we can keep it anything like PQRS also we can keep.
No. If you are using PQRS here, so you can also, you have to use PQRS here only, and okay, here also so this, PQ. Yeah.
So this should be same, right?
Yeah, it should be same. Yeah. So there exists ABCD means from this particular table. So from this particular domain variable which belong to student, there exists ABCD such that there are some conditions applied to that particular domain variable, right?
Okay.
Yeah.
Sir, can we write C greater than 75? After that, ABCD belongs to a student. Can we interchange the operand?
Sorry.
This operand can be interchanged. C greater than 75 first, and then ABCD belongs to a student.
No. At first, you have to declare the domain variable, right? That ABCD belong to student, and then C belong to 75. Right?
Okay. First we have to write this relation of the student with the ABCD, or whatever we have chosen here. There exists.
There exists means if you are using this variable inside our query, that is we are using C, so we have to specify that. But it's always better to write all the domain variable here. There exists ABCD.
First we have to write this one, right?
Yeah, this is a general way. And if there is one more condition, say age greater than 23, so here age stand for B, right? So I can add an age B greater than 23. Now you can interchange this. Either you can write and B greater than 23 and then C greater than 75.
Okay.
Or anyway. So
first one is required.
Will not matter, but
first one is required to be corresponding with this there exists. And after that, any condition can be put, right?
Yeah. If there is, if you want to add one more condition, you can add that B greater than 23. Or after that also you can write C greater than 75. No issue.
Okay.
Yeah, but we have to specify what is ABCD first, right?
So we need to include all the variables like ABCD, or we can miss one variable also, like.
No, here it is necessary. ABCD belong to student. Here you have to specify in the same order, and all the attribute you have to specify. And here there exists means if you are using any variable in the condition, then you have to specify. Like for now, I can skip this A, B, D also because I am only using C here, right? So there exists C, then bracket in this ABCD belong to student and C greater than 75. That's it. But this is necessary thing, right? You have to specify what is ABCD first here, right? Then only you can use that variable. Right. Okay. So let us discuss few examples. Now here we have to write down relational algebra, tuple relation calculus, and DRC expression, which will return the names of student whose age is greater than 25 or who enroll in maths. So name of student from names table, age, and the or who subject enroll in maths. Right. So these three attributes we have to use. Now, how to represent this in relational algebra? So project operator basically is used to display or return that particular variable. So here we want to return only name. So we have to specify pi name, and then there is sigma operator, which is used to declare the condition, like here age sigma.
Did not.
Plus, can anyone mute? Okay. Okay. So here in the relational algebra, like we have to specify like pi operator, that is project operator used for projection, like for any attribute you want to fetch. Then there's sigma operator, that is sigma operator for applying the condition, that is age greater than 25 or subject equal to maths, and then it's up, this condition is applied to the table student, right? So based on this condition, it will fetch the name of the student, right? Any doubt in this?
So sigma operator is for select.
Sigma operator is a selection operator, but basically we apply the filtering condition here. And project operator is used to if you want to return any particular name, any attribute. So the equivalent SQL query of this will be like select name from students where
Age is greater than 25.
Where age is greater than 25 or
subject is equal to mathematics.
Yeah, subject equal to mathematics. So this is a SQL query corresponding to this relational algebra. So here you can see select name. So project operator will work like a select operator, like in SQL, and from which table, like student. If I want to join these two tables, so here I can specify natural join symbol, student natural join activity. So that we'll discuss in the next example. And here I can also mention student natural join any activity, and then where clause, right? So this is the condition from age to this. So basically this is selection condition here. Sigma operator is used in relational algebra. Okay. Yeah. So this is about the relational algebra expression. Yeah. So
sir, how will we write this symbol?
Which symbol?
Whether these symbols is work in Postgres also?
No. It is just for logical purpose. Like it is not a SQL query that it will work. It will only give us like what data we have to find out, right?
And this is only for our understanding.
Yeah, understanding. Yeah.
Okay, got it. Oh, thank you.
So like one more thing here, except if I write pi subject and then student. So what will be the output of this? Just anyone, pi subject and from student table only.
Only subject.
Project subject from student.
Only subject will be.
Yeah. How many column rows will be there in this subject?
5.
5?
Three. Maths, English, Java.
Maths, English and Java. Because project operator will not consider duplicate value here. Okay.
Yeah, only 3 will be there.
Only 3 will be there. Okay. So these 3 will be there. Like any 3. Like only maths will be only written once, right?
Yeah.
This is an important point. Yeah. So project operator
in default project will work like a natural join.
Project? No. Project is basically we are just using the select in the SQL. It's corresponding to select, right? But here in relational algebra, project operator will not allow the duplicate value.
Okay.
Yeah, it will return only maths, English, and Java. Right? And what if I want to project subject, comma marks? Now in this case, how many tuples will be there? The subject say
5, sir.
Now 5 will be there because marks are different.
Because these two, these are the unique record, right? 70th maths and 56 maths. These are the unique records. Yeah. So it will.
But just in case, any marks, for example, the last 2 rows, they are 56 maths and 92 and 56 maths. Okay. Then 4 rows will be printed, right?
Yeah, those 4 rows will be printed, right?
Yeah. Okay. But that will be incorrect. I mean, theoretically, 56 are two different marks, but it will consider one.
Only one, yeah. It is in the case of relational algebra, right?
Yes, right.
Yeah.
Then one more attribute is required to be identified, right? For that.
Yes, I'm just taking one example in the case of relational algebra, right?
Okay.
In SQL, unless you use the distinct, then it will not fetch the distinct tuples, right? Okay. So this is about relational algebra, how to write this relational algebra query. Now we'll coming back to our TRC part, right? So here for a tuple T, there exists S which belongs to student, and the condition is applied, like S dot is greater than 25. This is a symbol of OR, and S dot subject equal to maths. And what we have to find out, like name. So we have to specify like this: T dot name equals to S dot name. And for a tuple T dot name, there exists S equal to S dot names, right? So it will print the name of a student having age greater than 25 or subject equal to maths. Okay, so this is one of the form of writing the TRC query. Or other form, what we can write, we can simply specify the attribute name that we have to return in the initial insert, like T dot name. Okay, but this T is not same as this T. Okay, so this T belong to student, and here it should be T. T dot age greater than 25 or T dot subject equals to maths. But this T is not same as this T, because this T is belong to this particular student's table, and this T is generalized tuple. Like for a tuple T, there exists some S, so that's satisfying this predicate, right? So you have to note down one thing. So either we can write in both the forms are correct, but this is more standard way of writing a TRC query. So we'll follow this form only, like first form. Okay, so
where this will be used, this TRC and this expression, where it will be used?
Say suppose if you are working in your organization and say I don't know any SQL thing, right? But I want some data. But I know this TRC and DRC, right? This is mathematical thing I can easily learn, but I don't know about SQL, how to write a SQL query. So what I can do, I can write a TRC query and give it to you. So you can convert this TRC query for me in SQL, right?
Okay.
Yeah.
This is a high level language type of thing.
High level, no.
Because it will be not, machine will not understand this one.
Yeah, machine will not understand, yeah.
Yeah.
Okay. So either way you can write this TRC query, but we'll follow this first form only, okay? Because what if I want to, like, there is one table student having 10 different columns attribute, and I want to fetch 5 attributes from them. So I have to specify T dot name, comma, T dot age, comma, T dot marks, right? So instead of writing this thing, we can simply mention in the predicate itself that T dot name equals to S dot name or T dot marks equals to S dot marks, right? Like this. It is not necessary that we have to use T here. Like in all the reference book, they are using T only, but it is just a general variable. You can use any variable here, like P or X, anything, right? So this is about the TRC.
In the TRC model, sir, there exists S belongs to a student. This is compulsory corresponding to T, because this will be by default, it will be there exists.
Yeah,
suppose we are using this standard form T such that there exists F belongs to a student, then a student relation will be by default there. Then other relations will come, right? Or operations will come.
See, we are using their existence because we are applying some condition on a student attribute, right? Like age and subject. So there exists S such that S dot is greater than 25, right?
Can we use here instead of activity also?
Sorry, where? Here?
Activity relation. Because
we can join these two tables, right? That we'll discuss in next example, joining of two tables.
Okay.
So this is about the TRC. We'll follow this thing only. Now, what is about domain relation calculus? So if I read this A, I don't know what does A mean, right? So first we have to look at this. What is ABCD? Now ABCD belong to student, right? So this is A, this is B, this is C, this is D. And what are the conditions? B greater than 25 means age greater than 25, or D equals to math, or subject equal to mathematics. And there exists B, C, D, right? And what we have to find out? A means name. So this is simple DRC query. Okay. So any doubt in this? Like here you can see I have not written A here. That is okay because we are only using B and D. Even if I skip this C part, that is also fine. But if you are using any variable inside the predicate, you have to mention there exists that particular variables, right?
But over here, the discussion is about A, right?
Yeah.
We have to find out names.
Names, right?
But there exists. We are not mentioning anything about A. Is that okay?
No, that is fine. Yeah, because
Okay,
we are
fine.
specifying ABCD that belongs
Inside
to
students. Okay.
So there exists some B which having age greater than 25 because we are applying the condition on this particular domain variable B, right?
Okay.
So there
fine.
exists B, so we have to specify that it is necessary here.
Yeah. No, I mean my question was specific. If we are not mentioning anything about A in there exists, that's still okay.
That is okay, yeah, because
fine.
we are not applying any condition on that, right?
Sounds good. Okay.
Now, which attributes are compulsorily required to be mentioned in there exist?
The attribute which are using in this predicate like B, D, right?
Okay,
so there
okay.
exists some D,
Yes,
there exists some D which satisfy this particular condition. Okay, for that we are fetching the variable.
That is required to be mentioned in this there exists.
Yeah.
Okay, okay.
Now moving on to the next example. Yeah. So we have to write as a DS expression. It will return the names of student along with sports. So sports from activity table, right? Whose age is less than 25 and have secured more than 75 marks. So name from student table, sports from activity table, and age and marks. We have to apply the condition on this too, right? Then how to write a relational algebra expression for this? Like simply project operator, what we have to project name comma sport, right? Comma is not required. Now inside the bracket we have to apply the condition. What are the condition? Age less than 25, age less than 25, and who have secured more than 75 marks and marks greater than 75. Now but in order to get the sports attribute, we need to join these two tables, right? So we are performing the join operation here. That is, this symbol is for natural join, a student natural join activity, right? So this symbol stand for natural join, and this cross stand for cross join. Okay, so this is for cross join, and here it is natural join. Okay, and suppose instead of this symbol, if I use cross here, then what changes I have to make in the condition? If I use cross here, then I have to add one more condition here. So what is that condition? Yes, anyone?
Where student's name is equal to activity name.
Dot name. Yeah.
S name is equal to A name.
Yeah. So we are not renaming here S, right? So we have to specify and students dot name equals to activity dot name, right?
Yeah, directly we have to put.
Yeah.
I mean, if we have to match natural join, if we don't match this particular natural join, then it's not necessary to give. Then altogether it will be a different result.
It will be a different result, right? Because you simply perform the Cartesian product, and based on that,
right.
it will give us the names and
sure.
Then repetition will come. In the result, two names and two sports will come, right?
An output of this.
Suppose we use cross join only instead of the natural join. And what will be the result exactly?
For one name, there will be 5 sports.
We have to check that because
for one name there will be 5 sports. So in all there will be 25 entries.
Yeah. So this is 5 into 5. That is 25. Suppose we'll get right. Then we have to apply the condition. The result will be different. Yeah. So yeah. One more thing I want to.
In most of the cases, you will use the natural join, right?
Natural join.
Yeah.
So in relational algebra, we use these two symbols for joining to this table, that is natural join, or we can use cross join also, right?
Yeah.
So yeah. So one more thing was there. Okay. Anyway, yeah. So this you understood, right? How to write the relational algebra expression for this particular. So if you have given this relational algebra expression, can you convert this into TRC? So let's see that. Now here, T. Now for tuple T, there exists S belong to student, there exists A belong to activity. Now here we are applying the joining condition. Here you can see S dot name equals to A dot name, right? Because S belong to student and A belong to activity. So we are joining these two tables based on if we mention this condition. And if I didn't mention this condition, then what will happen? Suppose if I am not mentioning S dot name equals to A dot name, then in that case, what will happen?
Again, Cartesian product.
It will be a Cartesian product between student and activity table, right? Yeah. So this is the condition S dot age less than 25 and S dot marks greater than 75. And what we have to find out? Name. So T dot name equals to S dot name and T dot sports equal to A dot sports. So from activity table sports attribute we have to find out, right? So this is the way to write the TRC query. So yeah, one more thing here.
But where is it? T dot sports equals A dot sports. But how come that? I mean, T dot sports doesn't have T dot sports. Can you just explain this part?
Yeah. So for a tuple T, we have to find out name of student and along with the sport. So whatever the attribute we have to find out, we have to specify like this. For a tuple T, T dot name equals to S dot name. So name from student table and T dot sports equals to sports from activity table. That is A dot sports. So whatever we have to find out, whatever we have to return, we have to specify like this in TRC query. So T dot name equals to S dot name and T dot sports equal to A dot sports. Suppose if I want to find out one more attribute, say awards, so I have to specify and T dot awards.
Oh, okay, got it.
Got it. A dot awards. Yeah.
Got it. Fine.
This is the general representation of
fine.
TRC.
So it means the result that will come should have the same name in the students and the in the activity table, sports and name.
Yeah. So this is equivalent to this project by comma sports.
Yes.
Yeah.
Fine. Got it.
In relational algebra, students natural join activity, how to find out that it will be a natural join or cross join?
So here you can see the symbol, right? So this symbol means natural join and cross means cross join. The simple two, only two notations are there.
Yes, but how we can get that there will be a natural join or cross join?
No, just looking at this relational algebra, we can find out, right? If there is this symbol, then we can say that there is a natural join, and if there is only cross, then we can say there is cross join between these two tables.
No, if there will be a MCQ and in one it is natural join and in other it is cross join. So how to figure out which one to select?
No. See, we have to check first our required problem statement. So we have to find out name and sport which having this particular condition. Means we need to join these two tables, right? So if we use the cross here, but here we have to add one more condition, that is student dot name equals to activity dot name. No, in that case, that option will be correct.
Okay.
If I didn't mention this condition, then that option will be wrong.
Yeah, fine.
Okay. And one more thing, like here in TRC, we are using this S for student and A for activity. Now, suppose if I want to use that S dot marks here, so how to do that? I have to rename this particular table name, right? So what is the rename operator in relational algebra? Yes, anyone? Which symbol we use for rename?
P, long P, elongated P.
This is row, right?
Row. Sorry.
So if I want to use S for student, so I have to specify row S, then student. Okay. Then natural join, then row A activity. Right. So then I can use S dot age and S dot marks here, right? If I'm renaming this student relation, right? So just keep in mind that row operator is used for renaming. Okay.
So in TRC model, this T dot sports is equal to A dot sports can be written before this S dot name. No, S dot age greater less than 25.
Yeah, you can write.
Leaving this first one. After that, whether it can be written first or the other thing.
Yes, but
First
we have to write this inside the bracket. Okay.
Yeah.
Even
Yeah,
if you
inside the
mention
bracket.
it first, that is fine because it is non-procedural language. Like it will only give us
Yeah.
information what data we have to find out, right?
Yeah. But order is
You
not
can write
important.
down. Now, order is not important here.
Okay. Only it should be inside the bracket.
Yeah, but
Okay.
we have to make sure like in which way we are writing this TRC expression. Okay. Say suppose I am not using any attribute from the activity table, like I am not applying any condition on this A, right? So I'm simply using this A for T dot sport equal to A dot sport, right?
Yeah.
So in that case, I can also write it as like I can simply like remove this there exists option and I can use like and a activity. Okay, so that is also thing because I am not applying any condition here.
Okay. Okay.
It is a different way of
Condition
writing TRC query, but we'll follow this thing only. Okay.
In that case, and we can use and operator.
And operator we can use like some reference textbook follow that, but we'll follow this thing only. Yeah.
Okay.
Yeah.
Thank you.
So now in domain relation calculus, yes.
In the TRC
in TRC, yes.
T dot name equal to S dot name, second last condition.
Okay.
Instead of S dot name, can we write A dot name?
P dot name.
A dot name.
A dot name. No, because we have to find out the name of a student along with. Yeah, we can write out A dot name also. Yeah.
Yes, since we had specified that S dot name equal to A dot name, so we can use either one of them.
Yeah, because anyway we are joining the table based on the name condition, right? So either you mention A dot name or S dot name, it will be the same name, right?
Okay, thank you.
Yeah. So here in DRC, see one more thing because there is okay. Let me explain. Now this A comma F. So what is A and F here? So there exists B C D, like where A B C D belong to student. So this is A B C D belong to student. And applying the condition B greater than B less than 25 and C greater than 75. And here I can see there exists EGH such that EFGH belong to activity. So this is EFGH belong to activity. And here you can say specify one condition A equal to E. Means this A is equal to E. Means name from the student table is equal to name from the activity table. So this condition we have to mention. Right. Now, what if I give A here, right? Because both are the same attribute, I can give A here and I can avoid this condition and I can mention A comma F comma G comma H. Okay. So what changes I have to make? Because we have to join these two tables, right? So what I have to do? I'm just simply instead of E, I am writing A here because both the attribute having the same name, right? So what will but I have not joined these two tables. How to join these two tables? Like if I don't want to mention this.
Sorry, can you just repeat the question? Didn't get it.
Okay, so you get till now, right? This ABCD belong to this table and EFGH belong to this table. And we are simply applying joining those two tables based on this condition, right? A equal to E. This is E. So what if instead of E, I write A here because both the name, both the attribute having the same name, right? So I can indicate by the same domain variable A here, right? I can do that, but I cannot mention this condition here now. Now, if I want to join these two tables, what changes I have to make in this? So what we have to do, we have to add, so we have to mention this A, means there exists A, then bracket open, and here you have to close the bracket. Outside the bracket, you have to mention there exists A. There exists A. So there exists A which belong to both the table. Okay, and we are joining two table based on this attribute there exists A. Okay, so outside the bracket, we have to add one more bracket here, and there we have to mention there exists A.
And there exists A can also be written towards the end of the bracket or in the beginning of the bracket?
No, in the beginning of the bracket.
In the beginning. Okay.
Yeah, so this is just one important thing, but in general, we follow this simple DRC. Okay, we are not going into the complex query.
While writing A outside the bracket, their exist symbol will also be there.
Yeah, there is exist symbol will also be there. There exists A.
There exists A.
Yeah.
After that, we can write only conditions for this.
Yeah, but we have to specify A, comma F, comma G, comma H belong to activity. Yeah. Instead of E, we are using A, right? So we have to specify that here also.
Okay.
Yeah. We are not going into the complex thing, but simple thing you should know, like in DRC, if we want to join, we have to specify this condition. In DRC, if you want to join two tables, we have to specify like this, and in TRC, we have to specify like this. Like joining of two tables are important, and applying the conditions are important. Okay.
Means there exist operator can be used inside the bracket also. Condition. There exists E, F, G, H.
Yeah.
This condition.
This E, F, G, H belongs to this activity table, right?
Yeah.
Yeah. So an operator is there.
Yeah, this is inside the bracket, na?
Yeah, inside the bracket only.
Okay.
No, this is the this bracket, and then this AND operator, and new bracket is starting here, right?
Okay. Two brackets are there.
Yeah.
Two brackets. One bracket is for BCD
Student
and
table.
second bracket is for EGH.
Yeah.
So, thank you.
So because this both TRC and DRC are non-procedural query language, we will only get the data, right? What data we have to find. So that's the thing. Any doubt in this TRC and DRC part? I think next example is similar to this only. Yes. So in this same example is there, but only the condition is applied to the awards, right? So age is less than 25 and awards won more than 3 awards, right? So we have to find out names of student and sports. So project operator is used. So pi comma sports, then this condition, and then we are joining these two tables, right? If I want to use cross join here, simply I can mention cross, and I can add one more condition, that is student.name equals to activity.name, right? Now in the TRC, here you can see the condition is applied on the awards and activity table, right? So here you can see there exists a belong to activity. I am joining this two table based on this condition, this filtering out the result. And here you can see a dot hours greater than 3. And what we have to find out, name and sports. So it will return name and sports, right? And same thing in DRC also, like A and F. So where there exists BCD, where A, B, C, D belong to student and B less than 25, and EF, GH. So there exists EGH, where EF, GH belong to activity, and G stand for hours here. So we have to specify in the same order, that is E, F, G, H. So G greater than 3 and A equal to E here, right? So that's okay. Any doubt in this relational algebra TRC and DRC part?
No, sir.
Yeah. So just keep 2 points in mind in TRC and DRC, like how to join the two tables. So we have to specify the common attribute like this, and whatever you want to fetch, whatever you want to return the attribute, you have to mention like this, like t.name equals to s.name, and then again t.sport equal to s.sport. And in the DRC, you simply have to mention the domain variables, right? So this is two things you have to learn: how to join the table and what we have to find out, right? Find out attributes. So how to, okay. So that's two things. But any doubt in relational algebra, TRC and DRC? Okay. So yeah, so AR diagram part, like if we go, you can go through all the tutorials, and you can watch week 4 activity session where Arup sir has explained very nicely about the AR diagram part. It is 2 hours live session. You can watch it at 2x. Okay, it will take 1 hour, but please watch that particular live session. Okay, I suggest you, those who are not there in the live session, you can watch that particular live session. It will be very useful for you, because I'm not going to explain ER diagram today, because it will take again 1.5 hour time, right? So I can simply mention these are the mapping constraints, like how we can represent many-to-many relationship, Here it is 1 to meaning this arrow indicate 1. Arrow means at most 1, right? So it can be 0 or 1, right? So it is 1-to-1 relationship, and this is 1-to-many relationship. It is many-to-one relationship, and this single line indicate partial participation, and this double line indicate total participation. Okay. And then these are the symbols used in the ER diagram. Entity class, weak entity class represented by a double rectangle, relationship type, identifying relationship type, attributes, key attributes. So you can go through this. Okay. But please watch all the tutorials in week 4 and week 4 activity live session. Okay. If you have gone through this, then I think it will be enough for this week 4. Okay. Now, any doubt in week 4? Any question regarding week 4 content?
Divisional operator.
Okay.
Actually, I have a doubt at a particular timestamp in lecture.
Any example you didn't understand or conceptual
Yes.
part?
Yes, example. It's an example.
Okay.
Conceptually, I am okay, but because of the concept, that example is creating the problem.
Excuse me, sir. Can you repeat the DRC? I'm not getting DRC's command.
Yes, 1 minute. Apul, first we'll take this TRC.
Yes, sure. Absolutely.
Okay. What you didn't understand is TRC?
How these alphabets are given and which table is given?
This DRC part. Or
Yes,
TRC?
yes, DRC.
DRC, no? Okay. Domain relation calculus.
Yes, sir.
Okay. So first, like, see, you can give any attribute name, any variable name to the table, but it should be in the same order. Like for students table, I can give anything like P, Q, R, S, and this P, Q, R, S, but we have to specify here, like P, Q, R, S belong to student. Okay, so we have to specify the domain variable here. Now, once we specify here belong to student and in the same order, so by looking at the table, I will get to know, okay, so P stand for name, Q stand for age, like this, right? And whatever you have to find out, like whatever you have to fetch, you have to specify before this vertical slash, that is inside the rectangular bracket, that is A, F. So here A means name from the student table, and F means, here F you can see it is sports from the activity table. So it will return name and sports. So basically you have to mention the domain variable in the same order of the, it is given in the relation. Hello, is that okay?
Yes, sir. Yes, sir.
Okay, yeah. You can watch the tutorial on this. Okay, no. I think the tutorial is on TRC. You can watch the TRC tutorial, tutorial 4.2. Yeah. Yes, Apul. Do you have that example?
Yes, I have.
Okay.
So in lecture 4.1, if you may go at 16.49 timestamp.
Lecture 4.1. Just 1 second. .1, 16 point. So which timestamp? 16 point. Hello.
Sorry, I was on mute. 16.49.
Okay. This example.
Yes. So Piyush, what is happening over here? In this example, the combination 2 and 3, 2 and 5, they are considered, but 5 and 6 is not considered.
Okay, so Lewis and Smith, right? So
no, not Lewis and Smith.
Yeah.
The column which is right to lecturer in module, right? The combination of that database and prologue is considered. Database, prologue. So see 2 and 3, it is database and prologue. That combination has been considered, but 6th, the database thing over there, that has not been considered as a combination with any of the tuples. I understood R thing should be common, and that's where the result is coming. But
Yeah.
the step before that, where at least the combination of 2 and 3, 2 and 5, 4 and 3, 4 and 5, why sixth number is not considered is my doubt. Conceptually understood, that should be fine. It will come out, the result will eventually come out as green, but the step between green and start, database sixth, is not considered, is what my doubt was.
2 and 3 we can consider, 2 and 5. Database and program 4 and 3.
Similarly, 3 and 6 also should be considered as one of the possible things. 3 and 6, 4 and 6, not
Yes,
4 and 6, sorry, 5 and 6.
Yes, you have to consider all the possible combination.
It has to be considered, right?
Yeah, but if we apply this, like result will only come out green, right? But it will not satisfy.
Right.
Yeah. Sir has only mentioned 4 conditions, but you have to check for all the conditions, right?
6-3 is also in here.
Yeah.
Excuse me, sir.
Database and program, yes.
Sir, can you take the same question from mock? That division question was there.
Yeah. So after this, we'll go into a mock test. Don't worry. First, we'll go to the division slide, and we're going to mock question. Yeah. Is that fine?
Yeah. Okay, sir.
Okay, so here is the mock test. Okay, any doubt in week 4 apart from this?
No, sir.
Okay, so if there is only that doubt, I think we can discuss then. Let me see. Question number.
Question. I don't know the question. Wait.
Division operator is there in mock.
Yes, sir. There was a question mock. Wait, I'm going to my mock.
Okay, yeah, I got that. Yeah. Okay, let us discuss that question. Okay, it is from week 4. Okay. So
question
one,
number
right?
11.
Question number 10, right? This one?
Yes.
Yeah. Yes, anyone. So what we have to check for the like a common thing, right? In the B. Right? So first A1, A2, A3. So for B1, A1 is there. A2 is there for B1. A2 is also there. For B1, A3 is also there. So B1 will be the possible. Now let us check for B2. A1, B2 is there. A2, B2 is there. A2, B2 is not there. So B2 not possible. Now let us check for B3. A1, B3 is there.
What are you checking, Piyush? I mean, you saw A1, right? And then what did you start to check?
No, we are actually dividing this R1 divided by R2, right?
Yeah.
So what we have to do, like we have to check for the attribute B in which it should have A1, A2, A3, all the corresponding attribute, right? Like in division operator, we usually do that.
Here, how are we saying we have to check attribute B? Because this question, I marked it as A1, and my understanding was like A1 is getting linked with all others. So A1, B1 is there, A1, B2 is there, A1, B3 also is there.
Yeah, A1, B1 is also, either way you can do. A1, B1 is there.
A1, B2 is there. A1, B2
No, we have to check for all the 3 attributes, right? Not attribute, rows here in the A. Like A1, B1 should be there.
We have to check.
A2,
A1,
B2.
B1.
Yeah. So A1, B1 must be there. Then A2, B1 must be there also. Like we have to check for this other combination also, right?
Okay. You mean to say the second?
No, check. What do you mean by check? I mean, what is the interpretation of check over here? Should it be like A1 has what all combinations? That is what we are seeing over here. What is it you mean by the word check?
Yeah.
My understanding was like the relationship. What we are checking, it has to match all.
It has to match all the attributes. Yeah. It's for all value of A, like we have to imply B from that, right? From this A table. So if you go to the like combination also, like what are the combination we have to consider, like Sir has considered in the lecture? Yes, anyone?
What, sir?
what are the combination we have to consider here? Like sir has considered 2 and 3, right? 4 and 5 in the lecture.
Yeah, so we will consider 1.
1. Okay,
write the number. First,
4,
write the number.
5, 6, and 7, right?
We will consider 1.
1 and 2.
1, 3,
1, 3, and 5.
4.
1, 3, and 4 or 5, no problem.
1, 3, 4. Okay, then. Like why we are considering 1, 3, 4 here?
Because
The
A1,
attributes are
A2,
there, right?
A3 is qualifying the conditions for B1. So we are selecting 1, 3, 4.
What condition is being qualified? Which condition is being qualified?
B1. Because B1 is qualifying the condition for all A1 and A2 and A3. So we are selecting B1.
What condition is being qualified? I don't understand. Where is the condition?
No. See, we have to check for all the rows.
This condition is for the division. For division,
A1, A2, A3 will satisfy this particular. For all the value which belongs to this A, there should be some attribute which satisfy all the any particular tuple, right? So if there is B1, we have to check whether A1, A2, A3 is there for all the B1 tuple, right? Same we have to check for B2 and B3 also. Like for A1, let us check. We have B1, B2, and B3, right? So AB divided by A will get the B, right? So B1, B2, B3, there are 3 unique rows here, right? Inside the B. Now, if for all the value of A, is there combination of B1 for all the value of A? Let us check in AB. So A1, B1 is there. A2, B1 is there. Yes, A2, B1 is also there. A3, B1 is there. Yes, A3, B1 is also there, right? So B1 should be the output of this, like one tuple. Now let us check for B2. A1, B2 is there. Like A1, B2 is there. A2, B2 is there. A2, B2 is not there. Means
No.
it satisfy for all the value of A, right? So A2, B2 is not there, so B2 will not come in the output. Now let us check for A1, B3. So A1, B3 is there. A1, B3 is there. A2, B3 is also there. A3, B3 is there.
Not there.
So B3 will also not come. So only option is B1, right? You have to check for all the tuples in the particular A, like whatever we are dividing with the corresponding this value, right? Maybe you can try out few examples. There is one tutorial also in this on this division operation.
Yeah, it is some complex.
Hello, Piyush sir.
Yes, Pradeep.
Yeah, previous session we explained about the division session, right? So in that, how the algorithm will work, so that we have discussed.
Yeah, so there is one big expression is there.
Right? You can try also, but for solving this question in the 1 or 2 minutes, you can directly write with respect to B1, you can write whichever is the value of A, right? B1, you can check the B1, you can write 1, 2, or 3. Hence the B2 also write A1 or A3, right? And for the B3, you can write A1 and A2, right? And you have to check all the relation, right? A1, A2, and A3. So only B1 is satisfying this.
Got it. Fine.
Yeah.
This is the one easy way, right? But you can also, there is expression also, you can also try this way also.
Yeah, so here you can see this expression, right? You can try to apply this in that particular question. Yeah. So basically we are projecting R minus S. So basically R is AB, right? And S is B. So basically we are projecting A from R, and then we are taking the combination with the S. Okay, you can try out this expression with the help of that example. You will get the same output. I think in the last session we have explained this. Yeah.
Okay. No, in case of only 2 attributes, it is easier to go directly by that, to just select it.
Sandeep. Okay, yeah.
I have one doubt from week 3, like on running any query with joins, like how many rows would come out. So that is something that on that, like I wanted kind of revision if I could get something.
Yes, yes. We'll go through the revision slide now. You can ask your doubt in that particular week. Okay, so we can discuss in one go. Yeah.
Yeah, sure.
Okay, so yeah. I think we have discussed week 4, so I think we can go for now week 1, 2, and 3 now. Yes, yes, Pradeep.
Yeah. Hello, everyone. So
Yeah.
my screen is visible to everyone, right?
Yes, sir. Visible.
Yeah.
Sir.
So first, in the first week, we in the first week, the content is why we use the DBMS system here, and also see the disadvantage of the file system. What are the disadvantages of the file system? So whatever the disadvantage of the file system, that are advantage of the DBMS system, right? So you have to also mind the key term also, like what is DBMS, what is database, what is schema, and what are the relation instance also. This thing you have to, key term you have to remember also, right? Like what is database, second DBMS, schema, instance, like right, these are the key term of the week 1. And so in the week 1, there is the what are the disadvantages of the file based by a Python system, that are the advantages of the DBMS system. So we can cover that part by comparison these two. Okay, so first we will see the comparison between the file handling via Python and DBMS. So first parameter is the scalability with respect to the amount of the data. So for the large amount data, it is very difficult with Python system, but in the DBMS system, it has the inbuilt feature. So it will deal easily with the large number of the record, right? So, and the next parameter is scalability with respect to change of the structure. So suppose ends the year 1 suppose one instructor relation is here. Okay, so it has 2 attribute, ID and name. Suppose if you want to add some attribute, right, like salary, so it is a very difficult to implement in the file handling by Python, but it is a easy. There is a alter command in the DBMS. By alter command, you can easily add or remove the column or the attribute from the database, right? And this is the next second parameter. And the third parameter is the time of execution. So for the large volume of the data in the Python file-based system takes the few seconds, but in the DBMS it takes only couple of milliseconds, right? So there is the difference in the second and the millisecond for the time of execution. And the next point is the persistent. So for the maintains the persistent in the database, it is the manually you have to update the file, but in the DBMS system, it has the automatic or the system induced mechanism. So by system, it is automatically done. And the robustness is for, there is a lot of manual intervention of in the robustness, but in the DBMS, you can easily by small minimum manual intervention. So you can do it. Okay. And the security perspectives in the in Python, it is very difficult, but in the DBMS, we seen in the view level, we can access to the different user as the different access of the user. In this way, we
Sir,
can.
what did you tell about this robustness?
Hence the robustness means, suppose you want to recover backup or maintaining some in, or the restore some file in the Python. So it is a lot of manual effort is there. But in the DBMS system, it is very easy. Okay, so couple of command is there. So that is the minimum.
Backup is the process that automatically it will be done. If you save the file or save this DBMS, DBMS also be in a file or folder.
No, sometimes it has to be done. It's the backup also. We did backup also.
Okay.
Backup in the sense of some if you have the store, suppose 1 month record you store, then backup this record, and after backup. Hello.
Oh yeah.
So
got it, but
yeah. And the security we discuss about in the security perspectives, in the DBMS we can user specific access. So for the different user we can provides the different view for that. So in this way we maintains the security, the DBMS system, and the productivity and the program productivity. So in the Python handling, we have to write
in the security.
Yeah.
This the security at OS level. What does it mean exactly?
OS level means if you implement some Python-based system, so you can see in the Windows file system there is no password in the Windows file system, right?
Yeah.
So once anyone open your Windows system, so he can easily access your file, right?
Okay. But here a database, particular database will be secured.
Yeah. In this we create something like the role, and we assign that role. Only that user can access those particular relation or the table or the view.
Okay.
This.
Yeah. Assignment is there in the SQL also.
Yeah.
Okay, got it.
And the program's productivity in the Python handling via file handling via Python, you have to write a lot of code, right? So first you have to maintain also the what you want. Suppose if you want to do some application development, right? So you have to also maintain the logic behind your application, and also additional that file handling also you have to write a lot of code. But in the DBMS system, that is, you can only focus on that particular application part only. So hence the DBMS part is taken care, database is taken care by the DBMS system, right? So in this way, the program's throughput is also increased, right?
Correct.
And the next point is the arithmetic operation, right? So Python has a lot of using Python we can do a lot of arithmetic operation, but in the DBMS system is the arithmetic operation are the limited. Okay, and the cost in the cost, it is a lower cost, yeah, but in the DBMS is a high cost than this file based system. Okay, and the next
mostly
point,
in the most of the cases this file handling is I think not beneficial.
Yeah,
so
that's why we use the DBMS system for the application development.
Okay, in Python also we can use this DBMS, no?
Yeah, we can. Yeah, so there is one in the week 7, the Python database connectivity. So how you can see how Python is connected to the database system.
Yeah. But
Otherwise,
file handling is not most beneficial. It is database is best beneficial.
Okay. So the next thing is the level of abstraction. So what our main motive is the DBMS system, we can extract the data efficiently, right? So for that, developer may use the complex algorithms to do that, or the complex algorithm or the complex data structure used in the data physical level, right? So to make it simplify, we use the 3 level of abstraction, right? So first one is the physical level abstraction, and the second one is the logical level abstraction, third one is the view level abstraction. And the physical level abstraction is the lower level abstraction that describe how the data are stored in the physical level, right? And the top of that, there is 2 data abstraction. The first one is the logical level, and the second one is the view level. In the logical level, we describe the what data is stored in the database and what is the relation amongst that relation, right, or the tables. So what data type is used, which attribute to if in that, or and the third one is the view level abstraction. So though we minimize the complexity by using these 2 level of abstraction, right, physical, there remains some complexity in that logical level also. That's why we use the view level also. So in the view levels, we maintain the security also. So suppose a clerk in the instructor tables, right? So this is instructor table, and the instructor table has the ID, name, and designation, right? And the salary. Okay. So if a clerk want only the list of instructor, right? So we only can provide these 3 attributes, right? In the view level. So we can hide this from the clerk. So these are the user of the view level. Okay. In this way, we hide the information for the security purpose from the. So this 3 is clear to everyone, right? So 3 data level abstraction. And after that, I want to introduce one term, so that is the physical data independence. So what does that mean, physical data independence? So whatever changes we do in the physical levels, that will not affect the logical levels or the view levels. So top of it, whatever, so depend upon this. So these are not affected by the changes in the. So in the future, we can change the data structure for the better performance of the database, right? Change. So maybe migration also database location. So that will not affect the logical levels and the view level. So this thing is known as the physical data independence.
Both one, logical level and physical level.
Yeah, top of it. No. Whatever changes in the physical levels, that will not affect the logical levels and the view level also. So
yeah, that is why it is abstraction.
Yeah. No.
But if
abstraction means we hide some details from the user, whoever want to use that. That is abstraction. We hide something, some information, right? That is the abstraction. And independence means whatever we change in that level, that will not affect the other level. That is the physical, that is the data independence.
This is independent. That was
yeah.
abstraction.
Yeah.
So Pradeep, just to understand this particular thing, independence properly, physical level, you have a table, right? You have a table, you are storing it. The first line says physical level describes how a record is stored. Now, when you say physical data independence, can you just give an example and show that independence between physical level and the view level?
So we mainly work in the logical levels. Whatever you work on, that's the we work. Suppose you work in the PG admin, right? So you deal with how so database are designed. Means you define your relation,
Yes, right.
Okay.
That's the logical
And so
thing.
what are
Correct,
the
right.
attribute also?
Yes,
But
right.
how it is
Happening inside the computer.
Inside
It's
the computer file system, how it is organized.
right.
That
right,
is
right.
hide from you.
And in case there is some update to PG admin, that will automatically happen, but our logical thing will not change.
Yeah.
Got it.
That
Okay.
is.
Thank you very much.
Yeah.
Thank you very much.
Yeah. And the next thing is the so physical data independence is clear to it. And next term is the between the logical levels. Whatever changes in the logical levels that will not affect the view level. That is known as the logical data independence. Right. So what does that mean? So same instructor tables, ID, name, and suppose the salary. Right. So there is one user, user one, right? Okay. So previously it was for the user one can see only the ID and name, right? And you add one attribute to the logical ends the instructor, suppose the address of the instructor. So it will not affect this user one, this view, right? So that is the logical data independence. So whatever change you can delete also. This also delete. Okay.
So that is basically dependent on how we write our views, right? Like how create view, how create views written.
Yeah. So that is significantly not means. But if you delete this thing, so it will affect, right?
Yeah.
So that is different thing.
Okay.
So next thing comes the database engine. So database engine has the three components. The first one is the storage manager, and next one is the query processor, and the third one is the transaction management component. Okay. So storage manager is the interface between the low levels, means whatever the file system you are using. So that is the OS file manager we use, right? So in that between whatever some programs, suppose some program request some query for the query that's the data, right? Request for some data. So first it will process by the storage manager. So whether the program are allowed to authorization, means check authorization, or so that things are taken care by the storage manager, right? So it will interact with the database system, and then it will return the output, means the data from the. So this is the so storage manager is basically work as the interface between the program and the database system at the lower level, and it is the one functionality of that. So it efficiently storing and the efficiently storing and retrieving and updating the data. So after that we comes to the query processing. So in the query processing there are three major components. That is the first parsing, then optimization, and the evaluation.
Here in this storage, what is the hashing issues? What is the meaning of this hashing issues?
Which one hashing issue?
Hashing issues.
Hashing issue.
What is
hashing issue means the storage system face some difficulty, so challenges, or that are the. So that are the specified. I think there is the three points that problems are faced by the storage manager. Okay. So storage manager, you will see what is hashing. So if I explain it in this time it is very confusing to you.
Okay. Let us forget.
So Pradeep, if we again take the example of PG admin, right? PG admin, will have three parts: storage manager, query processing, and transaction management, right? We don't know those particular terms, but all these three components make the database engine, which is the PG admin. Am I right?
You can think of it like this, but I will say this thing as this way. So this thing is a come under the physical levels.
Okay.
Yeah. So how it will internally function it. So don't relate this with the PG admin. So
Okay.
PG admin
database. Yeah, that's what I wanted to know. Database engine would be the physical level.
Yeah. How query is processing inside it, how query will, yeah. So PG admin is an integrated software. So everything is. I hope you differentiate those.
Like PGM admin, Postgres, other softwares may be there for management of the database, no?
Yeah. SQL
So
also.
This is the basic structure: storage manager of the and query processing and transaction management for the physical level.
Yeah, in the physical level, how it is working.
Yeah. Okay, got it.
Yeah.
I have here one question.
Yeah.
From this diagram, we can see the statistics are coming from separate database, or this should be from same database.
This should be from the same database, right? So what? So let me explain in the just to give an overview, right? So suppose any query is written here, so it first parse. So it check first any semantic or the syntactical error is there or not. So after that, it will translate it to the machine understanding language. So machine level or the low level language, right? So in that's the after that the same query is written in the relational algebra, right? So you can see in the details by previously in the week 1 practice session, I think we discussed about. So
I'm just concerning here about this. In this figure, it is showing separate database. I mean, that's how I confused. Yeah, you round off here. This is showing separate database, and data is there.
No. It's see the same data.
Okay.
Suppose let take.
I think this arrow should come from this diagrams.
Which one?
Now here you see that statistics about the data. It is showing separate database icon. I'm thinking this may be a separate database. And
no. So the statistic means suppose the data is static about this data. Suppose you want to see from the instructor tables, right? You want to check the salary which is greater than the 60,000, right? So if the data is in the sorted order, right? So it is the prior information to you. The data is whether sorted in the salary information or not, right?
I understand now. This one, I think this is the same database. Can you draw this arrow from database to optimizer directly here without showing up one more separate icon, database icon here?
This one.
Yeah. Can we draw that line?
Yeah. These are the same things. No. These are the original data, right? These are the original data. So whatever the information you store, right?
That statistics
statistic is different. So
yeah, that statistic is separate from it, and that is giving the statistics of that base data, and we are running our query on that data.
Yeah.
Okay. I understand.
Take it as a view.
Yeah. But the thing is, data and statistics both will reside in the same database. That's what.
Yeah.
Okay, I understand that. Thank you.
Okay. So in query processing, there is query processing.
Sir, can we say this execution plan means the whatever query it has been asked, everything has been converted by parsing, translation, and algebra and optimization. to make a machine understanding form so that data can be asked and evaluated by the engine. Is it so?
Yeah. So there is there two major component of the query processing is the you see the DML interpreter.
Yeah. And DDL.
Hence the DDL interpreter, right? DML interpreter, right?
Yeah.
So what is the work of these two is? So it will convert the DML commands to the machine understandable language, so we can execute in the evaluation engine, right?
Yeah.
Same thing we do with the DML command. So it can understand. DML interpreter will do. It converts the DML command only. So this will deal with the DDL command, and this will deal with the DML command. So it converts.
Yeah. Got it.
Yeah.
Got it. Yeah, same thing is.
So after that, here it's translated by that. So that after that, the evaluation engine will process this DML converted language or the low level language.
That will be low level machine learning will machine language will be there, right?
Yeah. After that, it will returns the query output.
Yeah. Okay. Fine.
Okay. So next component of the database engine is the transaction management. And the transaction management, you know about the transaction. So what are the transaction? Transaction are the set of or you can say the collection of the operation that are the performs a logical unit of work. So what does that mean? So suppose there is the one account A and the account B. So you want to transfer 50 unit from account A to account B, right? So is it clear to you the problem statement? What is problem statement? You want to transfer
account means bank account or user account?
Yeah, you can think about that also. So
okay.
So what that are the logical means set of operation. Any operation can be. So we will see that things in the transaction whenever. So I just want to give some flavor. Okay. So first, what are the operation? Can you tell me? So first, it reads the account of A. Okay. Right. So what is the balance of check the balance of the account A? So that is the read operation, right? Read A. Then it will debit 50 rupees, right? Then it will update write A means it update. Okay. And the next is then it will read. So okay. These are the flow is like this. RAA. This is the instruction 1. This is 2, 3, 4. Okay. And the B. And this thing is the write B. Okay. So you can see there are the 6 operations. So this collection of these 6 operations will known as the transaction. So it will particularly done a work, that is the transfer amount 50 units from account A to account B. Okay. So these are atomic in nature. Atomic in nature means if any transaction fail between any of here. So after you say after instruction for it failure, right? So it will roll back. So transaction objective of the one main objective of the transaction is it atomic of the nature, whether it will execute successfully or not at all. Okay.
Okay. The rollback means whatever has been executed, R A and A is equal to A minus 50 and write A, it will be again re-executed.
Yeah. You can say that in reverse order. In the reverse order means.
Okay.
So here it is minus, that is plus.
Okay, it will be done. Okay.
Yeah, compensation. You can say
compensation will be done and rewritten will be done.
Yeah.
But how it will be done, sir? If it crashes, suppose at the level.
We will see in this the transaction and the money. This is the small topic I just want to give.
Okay. Yeah.
So you will learn in the week 10.
Okay. Some methodology is there.
Yeah.
We cannot understand that at this level. Okay. Got it.
Yeah. So here you can see this. So before starting this operation, the database is consistent. So you have to maintain this condition consistency, because if it execute to all the instruction, that it will be consistent, right? Or otherwise is have to be rolled back. So that is the work of this transaction management component. Ensure that the database remain in the consistent state despite of the system failure or the transaction failure. Okay, that is the responsibility of the transaction management. And the second is the concurrent control manager. So in DBMS system, you can see, so at a time, not only one transaction will execute in the DBMS system. There is the multiple transaction is execute as concurrently execute in the database system. Okay. So you have to control in the sum. So otherwise it database got inconsistent, right? So that is the responsibility of the concurrency control manager. So it controls the interaction amongst the concurrent transaction. Okay. I hope clears about the transaction management.
Yeah.
Got idea. Okay.
Ideas only.
Yeah. Okay, that's it from week 1. Okay.
Excuse me, sir.
Yeah, sure.
Sir, I have some doubts from practice assignment of week 4, sir. Can you please?
Week 4. Can once it got completed, then you can ask. There is 2 remaining, so week 2 and the week 3.
Yeah, sir. First revision we should do then.
Okay, sir.
Yeah. Okay. Okay. Thank you, Subendra.
Yeah. Thanks, Pradeep. So my screen is visible.
Yeah, visible.
Okay. So basically, in week 2, we have learned basics, relational algebra expression and SQL. So we'll go one by one module. So in module 6, basically we have learned various types of attributes like date, varchar, and the date, numbers, and the various types of attributes. And we have learned then schema. So basically there is a relation R and the schema defined like this. These are the attributes A1, A2, and these are the attributes. Then we have learned what is instances. The current values of a particular moment of a relation is an instance of the relation. Suppose particular relation current particular times, what are the values is called instances. Then we have learned various types of keys like super key, candidate key, and the primary key. Super key is the list of values, the list of attributes that can uniquely identify every tuple is called super key. And the candidate key is the minimal set of attributes that can identify each tuple is called candidate key. And the one of the candidate key is known as the primary key. Suppose let's take an example. Suppose there is a relation schema R, A, B, C, D. Suppose we can say that, let's take example A, B, C as a super key, and the candidate key, suppose A, B uniquely identify all the tuples, and or the BC, A, B or the BC is the uniquely identify all the tuples. Then primary key would be one of the candidate key like A, B or BC would be the candidate key. Then we have learned secondary key, then the alternate key. So candidate key other than the primary key is not known as the secondary key or alternate key. Then the simple key, that it consists of a single attribute. Then we have learned composite key that consists of more than one attribute to uniquely identify each tuple in a relation is called composite key. Then we have also learned foreign key. Foreign key basically relationship between the two tables or more than that tables. Suppose suppose there is instructor table, suppose name and the department name and the salary. And the one is another table is suppose building. There is department name and the block. So we can say that this is the foreign key and reference to this like this. Then we have learned procedural language. So in procedural language,
can you explain keys once again?
Yeah,
I'm getting some doubt on that.
Hello,
please explain the keys again.
Keys, super key, candidate key, and primary key, right?
Yeah.
Okay. So super key is the set of attributes that can uniquely identify each tuple is known as super key, right? Suppose there is a relation R and the attribute are A, B, C, D. Suppose let the super key suppose A is the attribute uniquely identify each tuple. B also attribute is uniquely identify each tuple. So super key will be like this: A and the AB, then AC, AD. So set of attributes which can uniquely identify each tuple is known as super key. So you got it, super key?
Yeah. So in this case, A would be super key or B would be super key, or the combination of A, B would be super key.
So if A is the uniquely identified of each tuple, so A is also be super key, AB also be super key, AC also be super key, AD also be. So set of attributes which can uniquely identify each tuple is known as super key. That's it.
How many super keys if we want to count, then also we have to write?
Okay, see, suppose let's take relation R, A, B, C. Suppose let's take A is the candidate key. So how many super key? Then A, B,
and AC.
And AC, then A, B,
ABC.
ABC also a super key, right?
Yeah.
So that's it. So you can in this you can easily suppose there is 3 attributes, right? So one is candidate key. So super key, numbers of super key will be 2 to the power 3 minus 1. So 2 to the power 3 2 to the power 2 equal to 4.
Got it.
Yeah. So and the candidate key. So minimum set of attributes which can uniquely identify each tuple is known as candidate key. So in this relation, A will be the candidate key and the B will be the candidate key. So A and the B will be the candidate key. And the primary key, one of the candidate key will be the primary key. A or B will be the primary key. So you got it?
Yeah.
Okay. Then we have learned procedural language, procedural programming, and
so I have a question.
Yeah.
In relation ABCD, if we say A and B are the candidates key,
yeah,
right? Can you just explain in terms of this formula? I mean, 2 raised to the power 3 minus 1, it was clear, but when we have 2 candidates key, then how this formula will work?
Okay. So candidate key is A and the B, right?
B,
okay.
Right.
So with the help of only A is the candidate key, how many super key? 2 to the power 4 minus 1, right?
2 raised to the power 4 minus 1, right?
So how many is?
8.
8.
8. So if the only B is the candidate key,
again same 8.
Again
2 to the power 4 minus 1, 8. So there is some common values, right?
Hmm.
So So if there's, suppose let's take AB, so say some common values will be there, so like AB, it contain also AB, some tuples, it contain also some tuples. So if you consider only AB is the candidate key, so how many will be the super key?
4.
2 raised to the 4.
Yeah, 4. So you have to subtract, right? 8 plus 8 minus 4. So 8 plus 8, how many?
How did we reach to 4? How did we reach to 4 by AB?
Okay. Yeah. So let's.
Suppose we can say AB can be taken as a one unit. Very simple.
Yeah. Yes.
Then
So
1, 2, 3 is that.
In
AB,
the set theory, you have learned number of A union B equal to number of A plus number of B.
Yes. Minus A intersection.
So
Yeah,
from this formula, you can. So you got it, or can I explain once again?
I know this formula, but again, I'm not able to relate AB equals 4, how it is coming.
Okay. So let me one blank express. Okay, 1 minute. My screen is visible, right? Means what?
Yes.
Yeah, visible.
Okay. Okay. The candidate key is A and the B. So if you take A is the candidate key. So numbers of super key will be that 2 to the power 4 minus 1, right? So this will be the 8. So what are the attributes? If you say A, then AB, then AC, then AD, then
ABC,
then
ACD,
ACD, then
ABCD.
1, 2, 3, 4, 5. Yeah, ABCD, like this, right? Hello.
One left.
Yeah. Can you tell?
One left.
Yeah, some. Yeah. So if the B is the candidate key, only B is the candidate key. So there will be 2 to the power 4 minus 1. That will be 8, right? So what will be the candidate key?
BC.
Yeah, BC.
BD.
BD.
BA.
BA.
BCD.
BCD.
BDA.
BDA.
BACD.
Okay, so BACD. Okay, if you see,
but what is, it's only coming to 7. How come 8 is there then?
Yeah, there will be 8,
which else will be there then?
Okay, let's
BDS.
ABD in first.
Oh yeah.
BDS.
BAC, sir.
Okay, let's write one sir. So B, then BC, then BD,
EA,
then ABD. You can write ABD, right? ABD is the missing. So that will come by 8. Don't worry. Okay. So if you see some like AB, and there will be, this is the means repeating, right? So you have to subtract, right? Hello.
Yeah. Okay.
So if you see what are the common values with the help of AB is coming. So if you see take single attributes, AB is the take single attribute, right? Hello.
So that will become 2 raised to power 3 minus 1, which will come to 2 raised to power 2.
Yeah.
Okay.
Yeah,
fine.
exactly same.
Yeah. Okay.
So you got it?
Yes, got it.
Okay. Okay, then in module 7 we have learned basically relational algebra, basic things about the relational algebra, like selection operation. It selects the rows or tuple. Suppose if you want to filter some rows, then we can use selection operator. It denotes
one surrogate key, I think.
Yeah.
Surrogate key was also there. What the synthetic key? What about that?
Oh, synthetic key basically suppose okay, let's give one example. Suppose I'm giving one example so you can relate with the help of this, right?
Yeah.
Okay, suppose there is a 10 class, there is two sections, A and B, right?
Yeah.
So and it consists of like student and table name is student and the roll number and the name, right? And the section B also suppose student,
Same.
roll number,
Name,
then name. And suppose let's take some value that will be easily some instances. So this is section 1, suppose roll number and then name. Suppose roll number 1, sorry, name is Ram. Roll number 2, Raj.
Sir, what is the question?
Is asking about
surrogate key,
synthetic or surrogate. Suppose let's Rakesh. This is the section 1, right? And another is section 2. Section B, sorry. Roll number and the name. So there is roll number is 1 and suppose also Raj, sorry Ram, and 2 suppose Vikas, and 3 suppose Suben. Suppose principal wants in one sheet, means in one table both the sections, section A and section B. If you see that none of the attributes are uniquely identified, right? Suppose both the table, if you join both the table, none of the attributes uniquely identify each table, right? Not roll numbers or not RAM, right? Hello.
Yeah.
True. So for that we can we can artificially generate another tuples like index numbers, like we can assign index numbers like 0, 1, 2, 3, 4, 5. So this is the surrogate key. We can artificially generate one synthetic or a surrogate key so that we can uniquely identify each step. That's
we have to put this indexing in the SQL.
Indexing, index means you can that computer is automatically generated. You can say that index or something something others that computer means easily generated.
So you can use serial
serial number. You can use serial numbers or other things.
So so just think about the case like during our school days, we don't have any roll number. So what teacher used to do, we have to write our name in the sheet, right? And the sequence in we write our name, that sequence will become our roll number, right? That is a synthetic, like artificial key, right? Synthetic key. Like if you don't have any attribute, we specify which identify all the uniquely attributes uniquely, then we can create one synthetic key. So in this case, we can create one serial number, and we can make that particular serial number as a key, right? So key is basically it should uniquely identify each attribute, each tuple, right? So that's the case. Yeah.
Piyush sir, I would like to add something. You can say, oh, what is synthetic key means whichever's the key that is used to identify each tuple that is not derived from that data. Okay. So for example, suppose you apply for the Aadhaar card, right? So you put your name, address, everything, every details. Then it will generate one code that is your Aadhaar number. Okay. That is generated by computer. That is not related even your data. So whatever you provided. Okay. So that is synthetic.
That is also synthetic.
Yeah. Okay.
Means this synthetic key is generated by the computer itself.
Yeah, computer means, or that is not derived from that data.
In database attribute.
Yeah, that is not stored. That is not in the schema, right?
No. That is in the schema also. So that is not derived from that data.
Whether it will be visible in the table, in the schema, in the Postgres, suppose such type of situation is there, then whether this table has a surrogate key, it will be visible in the schema table also.
Yeah. That's why it is used for you want to identify the tuples, right? So if it is not in
the design, we have to put, right?
Yeah.
Okay.
In Postgres also there is one data type that it will generate unique number for each inserted row. So every time you insert a new row, it will create one unique ID for that particular row. That is also there in Postgres.
Okay. Let us proceed.
Then we have learned project operation. Suppose if you want to select some columns or attributes, then we use project operation. Suppose there is a relation R, there is A, B, C. So you want to select A or C columns. So you can write by AC. Then R. This is a smaller. Then we have learned various type of set operation like union, difference, and intersection. So basically, if you want to perform some set operation, there must be a union compatibility. So union R union S denoted S, and the difference R minus S, and the intersection defined R intersection S. Then we have learned Cartesian product. So basically, Cartesian product is
selection. In the selection, it is only for the rows only.
So yeah, this project operation, right?
No, selection. Selection is only for the rows.
Yeah, only for the rows of tuple. If you want to
only...
no, if you want to put some condition on tuple, that's why we use. Suppose if you want to there is a suppose a relation R A B C. So there is a suppose 1 2 3 4. Suppose if you want to that A should be greater than 5. So if you want to suppose from some, if you want to get that A should be greater than 5, so you can use sigma operation. Then the A greater than 5, the R. That is, suppose it's perform on the tuples,
but it will give the result, the output.
Yeah, it will give the it will
only rows only, right?
Yeah, only rows. Suppose there are 6 7 8. Suppose there are 3 rows, so it will give the 3 row result, right?
Yeah, the output will be only rows, and the project operation the output will be rows, right?
So
conditions are different.
See, selection operation, it selects some tuples. Suppose if you want to perform condition on tuples, then it is selection operation. And project operation, it select columns. Suppose if you want to only you get 2 columns, A or C, then we use project operation.
Yeah, it operate on the column. Yeah, parameter is column, that parameter is rows. Okay.
Yeah.
Fine. Okay, thank you.
Then the natural joins. So if the 2 tables some common names, then we perform natural joins. Okay. So then in module 8, there is history of SQL. So you can go through the slides. Then we have learned data definition language, how to create tables, how to drop tables, how to modify, how to alter the tables. So in detail commands.
Can you quickly go through the joins? I mean, we have just seen, but if you can just give a quick thing about join, only natural join is there.
Yeah.
The other join, inner join, and all that. Next.
In week 3, I think that will.
Fine. Okay.
So on data definition language, so we have learned how to create table, drop tables, and the alter table etc. And we have learned now DML, data manipulation language. So we have learned how to modify the tables, like how to update the records, how to insert the record, and how to delete the records, like this. And the basic SQL structure is select, from, then where. So basically select was select the list of attributes from in the result of a query. So basically if you want to select this many attributes, you can suppose there is relations are A, B, C, D. So you want to select only A or B, so select A or B. And the from, then the table name. So the from clause list the relation involved in the query. Suppose how many relation involved in the query. So this is the from clause, and the where you can put the conditions. You can specify conditions in the from clause. And then in module lines, we have learned about the Cartesian product. Basically, a Cartesian product is a cross product. Suppose in a tables, suppose there are 5 rows. In a tables are 5 rows, and the tables are 6 rows. So Cartesian product will return 30 rows. So yeah. Then we have learned rename operation, how to rename the columns, structure. Then sorry. So we have learned string operation, how to manipulate the string. So basically, percentage means it character matches any substring, so it matches any string, and the character single underscore means the character matches only all character or any characters. Then order by, so basically if you want to sort the some particular columns, so then we use order by clause. So basically order by default ascending. So if you want to put or if you want to sorting in descending order, then you have to write order by some column name, suppose A, then descending DSC. So we have learned stop phase column. Suppose if you want to phase only some records, suppose only 5 records, only first 10 records or first 15 records, then we use select top clause. In Postgres, we have used limit clause. In the top clause, we have limit 5 or limit 10, like this. So basically, then we have learned in operators.
What is this in the Postgres, sir? This limit 5 means?
Limit 5 means syntax. Yeah. So only it fetches only first 5 records. Suppose let me take example.
The syntax of this limit in the Postgres.
Yeah. So suppose there is a instructor relation. So at a name, then salary. So if you want to paste, so top to highest salary, name of the instructor, top to highest salary. So we can say select name, then salary from instructor, order by salary, descending, then limit. If you want to fetch some, suppose only two instructors, so it will fetch the highest, top 2 highest instructors name and the salaries.
Limit 2 is okay. Only limit is that.
Yeah.
Okay.
Only and then we have learned in operators. So basically, if you want to so if you want to multiple, suppose there are if you want to So basically that operator allow you to specify multi-value values in a where clause. Suppose it's about use of multiple or operator. Suppose there are name and the salary. Suppose if we want to find the name of instructor and that also another in the department name. Suppose if you want to find the name of the instructor which belongs to the music and the music or the biology department, so you can easily write select and name from instructor where department name in so music and the biology. So if you want you can also write in the where condition without the help of in condition. You have to write multiple where, like suppose where department name means music or department name is biology. Then we have learned also about multi-sets like accept all, select all. So these are the very important points.
In operator can be replaced by the other operators, right? No?
Yeah, but you have to write multiple times for condition, right? So that's why we use in operator.
Okay.
And then we learn accept all and the union all in the multi-set operation. So these are these two important points. So and in module 10, sorry. So then we have learned various types of set operation like union, intersect, accept. So then we have learned basically about aggregate function. So return average value and the minimum return minimum value and the maximum return max value and the sum return sum value and the count return numbers of values.
Only 5 aggregate functions are there, or other names are
there are basically 5 aggregate functions.
Okay.
Yeah. So and then we have learned group by. So basically if you want to groups on particular columns on same value, then we use group by. And then havings. So if you want to put condition after grouping, then we use having condition, having clause, sorry. Then one important points, all aggregate operation except count stars ignores null values. So let's give one a question. Suppose there is a name and the numbers. Suppose A numbers is out of 10 is 5. B, he did not give exam, so this is null. And C, suppose he gave exam, so this is the suppose 7. So select average, sorry, average number from this is suppose table name is suppose B. So what will be the output? Anyone?
6.
Yeah. So basically it will 5 plus 7 divided by 2. It will be 6, right? So yeah. So yeah, then 3 will be covered by Anjana. So over to Anjana.
Sir, this is having and where.
Yeah.
Can you give some light on that? Having and where will make some difference.
So yeah. So sorry. So suppose there is a table. So in her suppose role, so department name is suppose name, department name and the salary. So name suppose A, department name is music. I'm writing the salary is suppose 50. And also suppose another instructor name B, and the department name is also music, and the salary is 50K and the 30K. And another instructor name is C, and the department name is biology, and the salary is 40K.
Yeah.
The D department name is suppose biology and the 40K. So suppose in where clause, let me explain having, then I will understand the where clause. Suppose if you group the according to the department name, right? Hello.
Yeah.
So then
Yeah,
after that you want to put some condition, then we use having clause. Suppose you want to find the particular departments, some salary is greater than, we want to find the name of the department.
Okay.
So
Group first group by will come, then where having will come.
Yeah, you got it, having and where. So if you want to condition after the grouping, then you use having clause.
Okay.
And
sequence will be select from group by having.
No. Yeah, select, then from, then where, if you want to put some condition.
Where group by.
Yeah, group
and
by.
Then having.
Yeah. So yeah.
Okay.
You got it?
Having is an optional. Okay. There is compulsory. Got it. Thank you.
Yeah.
Thank you.
Okay. So week 3 will be covered by Anjana. Over to you, Anjana.
My screen is visible, right? Am I audible?
Yeah, audible, ma'am.
Our screen is visible, right? Ma'am.
Visible.
Okay. So now we'll be discussing about week 3 and what we have covered in week 3. So we have started from the basic SQL features, which included select, distinct. So what happens in select, distinct basically is, so when we use a distinct keyword in the select clause before a particular column or attribute, what it basically does is it will remove all the duplicate values from that particular column. Now we also have one more keyword saying all. So what happens is, say for example, we don't want to remove the duplicates, we want to retain all the duplicates. So what we can do is we can use the all keyword in the select clause before any particular column or attribute instead of distinct. Then we have also learned about Cartesian product, which is also known as cross product or cross join. So as the name suggests, it multiplies the number of rows in the first table with the number of rows in the second table. Then we have gone through the rename operator, which is used in order to rename any particular attribute or table for better readability. So we use the as keyword. Even if we don't use the as keyword, we can still rename a particular attribute or table. Then some more features included and or, which were used in order to specify more than one condition. Then we use some string operations, the like operator, where we use the symbols such as percentage and or underscore. So percentage, what it does was it means that it could be any character, or there could be any character or string. There could also be no characters. However, underscore meant that there should be one character, single character must be available. Then we went through some more set operations, which included union, intersect, and except. So what the set operations does is, they won't return any duplicates. They will simply remove the duplicates. So in order, if we want to retain the duplicates, what we can do is we can use their multi-set versions, which are union all, intersect all, except all. Then we also went through the aggregate functions, which included max, min, average, count, sum, which Subhendu has discussed in the previous slide. Then in the next module, we learned about subqueries or nested subqueries. So subqueries can also be used in like the where clause, in the from clause, in the select clause as well. So at first in the where clause, subqueries can be used by using certain set comparisons, which were some of the operators which were from the set comparisons which we used for using subqueries in the where clause are some, any, all, exists, not exists, and unique. Then we also use set membership in order to have nested subqueries. So the set membership was we used in operator. Then subqueries can also be used in the from clause, in the select clause. Then we also did some modification of the database, deleting from the table, then inserting new tuples into a relation, then updating values. After that, in the very next module, we went through the join.
Ma'am, here in the set in the subqueries.
Yeah.
In the nested query, can you give some more example for structuring this subquery? The tips to structure the subquery. Some problem statement is there. We want to construct nesting. Then what should be the technique to construct? Where to start? From select or from the last one?
It would be better if the question is quite simple and we just need to like
if it is complex. In the case of simple, it is okay. No problem.
So in the select clause, if we use a subquery in the select clause, what happens is that is a scalar subquery. So what happens in scalar subquery is it will take only one column. It will select only one column or attribute, and it will only return one column. It won't return any more columns. So in order, if we if we use a subquery in the select clause, then we need to keep this thing in mind that if the question asks for one column only, then we can use that scalar subquery in the select clause. If we use it in the from clause, then we'll have to use it with the keyword with. I hope you are aware of the with clause. Right?
Where table is required, the output is table.
Sorry?
Where output is table, then how to construct this nested queries?
I'm not able to get you.
Suppose some output is a subquery gives a table, and that table is being used by the another query. In such cases, how to construct this subquery? Where to start?
Yeah, see, simple. You can, based on the problem statement, you can go through it. Like, for example, if you want to find out the highest salary from of all the employees, like, so you can use simply salary greater than all of the or some of the instructors. So after some, you can use select salary from the instructor table. Like, so this is one of the simple use case you can do. It will be better if you can go through any questions. If you have problem statement, it will be better.
Yeah, problem statement will be there than which is not here. Okay.
You can practice out those 30 questions we have released. In that we have used this all those things. Yeah.
Okay.
Yeah. Yes, Sanjana.
Okay. So, any doubts in the subquery part, anyone? Okay. So we'll move to the next module that consisted of the join operations. So someone was asking to explain join operations. So what basically join operation does is it takes two relations and then return as a result another relation. So it basically combines two relations and then form another relation. Then there are a number of join operations which work differently. So at first we have the cross join. So if you all are aware of the Cartesian product, then a cross join is nothing but a Cartesian product. So it returns the Cartesian product of two relations. That is how a cross join basically performs. Then another type of join is inner join. So what happens is it combines two tables that have matching columns and create it into a single table. Now it also uses some as specified in the So for comparing, as a comparing operator, it uses the on clause as well, the inner join. So so after that we have outer join, which it also returns inner join returns the tables that have matching values, right? What outer join does is it also returns the tuples which do not match. So there are a number of outer joins which are left outer join, right outer join, full outer join. So what happens, I'll just give an overview of left outer join. Right outer join is just the opposite of left outer join. So what happens in left outer join is it will return all the tuples that are present in the left relation and all the common tuples from the right table, the common tuples between the left table and right table from the right table. So the not vice versa actually. So in right outer join, what happens is it will return all the tuples present in the right relation and the tuples that match with the right table from the left table basically. Then what happens in full outer join is it will return the tuples from the inner join at first. Then it will return the unmatched tuples from the left table and then the unmatched tuples from the right table. So this is how a full outer join works. Then finally we had self join, which basically joins a table with itself. So is joins clear? Anybody, any doubt in joins?
The number of rows in the left outer join will be the number of rows which is in the left table, right?
All the tuples that are present in the left table.
Left. Okay.
Will be
and
returned.
In the right, it will be number of equal to the number of rows in the right table, right?
You are asking for left outer join, right?
Yeah, in the left it is okay.
Yeah, left all the tuples will be returned, and for the right table, only the tuples which are common with the left table will be returned.
Okay. And other which are null, then null will be posted. It is so, no?
Sorry.
Null if it.
Yeah, null.
Null.
Yeah.
Suppose some column is not having some values, then null will be posted.
Yes, that's right.
Okay.
So join. Anyone any doubt in joins?
No, man. Okay, fine.
Okay. Then,
full outer join is full outer one, full outer join.
Yeah, it will return all the tuples which match and which does not match. All the tuples.
Okay, both. Okay. In the highest number of the column, highest number of the rows will be number of rows, right? In the full outer join.
Yeah.
Right. Thank you.
So then we also studied about views. So how views helps in hiding certain data from certain users. If you all can recall the levels of abstraction where there were a number of views for certain users. So yeah, view is basically a virtual relation. It is not physically created. So what happens is at the time when we use the view, the query expression used while creating the view will be executed. Like when we are using the view that we created. Then we also learned how views are created, what is a materializing view. So as the definition says that it creates a physical table that contains all the tuples in the result of query defining the view. So that is materializing a view. Then in the next module, we learned about the integrity constraints, referential integrity. So on a single table, the integrity constraints used were not null, where some attributes should be not null, like the value, none of the values should be null basically. Then we had unique constraint where there cannot be two tuples having the same value. Then we had primary key. Then also check P here is the predicate. So what happens is so like these check constraint is basically used in the create table. Does anybody want me to show it, or are you aware of it, the check constraint?
Which one, ma'am?
Like the check constraint, check P, if you can see. There is an example given by sir in the slides also.
Yeah.
Yeah, so it's fine, right?
In the last, after primary key, we write this check.
Yeah.
If we can see, it will be useful if it's not a problem.
Yeah, sure. So say for example, we are creating a table, say create table, say department, and we are taking the values as department ID, int, and this is the primary key. I'll just write it as PK, okay? And then we also have, say for example, department name, okay? Varchar. Then what happens is, say for example, we write down check, and then in bracket, we write down D name, and then the in operator, and then in bracket, we write down CS, ME, mechanical engineering, electrical engineering. So what happens here is, like on the value of department name can be CS, ME, or EE. It cannot be something else like IT. It cannot be that. Since we have mentioned the like we have specified here in the create table itself using the check constraint that the D name could be CS, ME, or EE. So if there is another value in the department name, then it will violate the condition basically. So is it clear?
Yes, thank you.
The message will come, ma'am, or only it will not accept?
I guess it will give an error.
Okay.
Yeah, you can try it on the PG admin.
Okay.
Yeah. Okay, then we studied about referential integrity, which had on delete cascade or on update cascade. Now, say for instance, we have two tables, faculty and department. And the department code, which is a primary key in the department table, is a foreign key in the faculty table. Since both the tables are independent of each other, now what happens is, say for example, in the department table, we have like included one more, we have added one more department. And then what will happen is it will be updated in the department table only, right? It won't be updated in the faculty table. So what it will lead to is, it will lead to inconsistency of data. So for that reason, what we can do is we can use the cascading actions like on delete cascade or on update cascade, which will ensure that the changes made will be made in both the tables. Like if any particular tuple is added in one table, in the like referencing table, in the referencing attribute, then it will be updated in the other table also, like, yeah, in that manner.
And this syntax will be added where references will be made, right? Only
like this on delete cascade and on update cascade, right? It will be used in the create table only.
Create table, and where, at which line? Where
at the end. At the end you can use.
At the end only. Okay.
Yeah. Okay. So after that, we have also gone through some built-in data types, which included date, time, interval, timestamps. Then we also learned about index creation, creating user-defined data types. Then we learned about authorization, what privileges should be granted or revoked from a particular user. Then creating roles and granting roles to the users. That all came under the authorization part only. So after that, in the very last module, we learned about some advanced SQL, which included functions and procedures, then table valued function, which returns a relation as a result. Then we also have gone through the like procedural language constructs, which included while loop, for loop, repeat loop, if then else, and case. Then we also studied about triggers, how it is a set of action that gets performed in response to insert, update, or delete operations on a specified table, how to use triggers and how not to use triggers, when not to use triggers. So yeah, this is what we have learned in week 3. So any doubt? Anyone?
Can you put some lines of trigger also? Trigger is example with the trigger.
Pradeep, would you like to take that?
Yeah. In trigger, you can say the trigger is the definition, a set of action to be performed in order to any event Suppose what is trigger? For example, suppose the referential integrity. How you can check the whether it violates the referential integrity or not? If you want to insert, okay. Anjana, can you stop?
Yes.
Okay, just so my screen is visible.
Yeah, visible.
Yeah. So suppose there is two tables. This is the table 1 and this is the table B. Okay.
Yeah.
And this is the XY. And this A takes the reference value, means W, and the Z. Okay. Take the reference from the X. Okay. So if we, and these are the 2 or 3, there is something else. So if you want to insert some value other than 1 or 2, right? Insert. So suppose you want to insert 3. So how you can know this is violates the referential integrity? That is because of the trigger. So if any event occurred in the database, hence the event are insert, delete,
update,
and the update. Update. These are the event. So how you can know this particular violates the integrity constraint? So that is because of the trigger. So if you want to insert the value that is not present in the B table X, so that is also the means that the trigger will automatically invoke. So that means the SQL statement that is automatically if invokes, that is known as if any event occurred, so that is known as the trigger. Okay, so you can define the trigger. These are the event. Okay, event is trigger is clear to you. What is trigger? So trigger is not you explicitly call it. It by default, if you defines the trigger, it will automatically got executed in action of this event, right? So insertion, deletion, or the update if you want to perform this thing, and this, and the time is when you want to execute your trigger. So before insert or after insert. Okay. After and so before. Okay, so you can see there is the six combination are there. So after insert, after before, you can see the event and there is the one thing is called as action. So if this thing happened, so any event occurred or it violates something or you want to perform any action, right? So you can write any function here. So suppose if any delete occurred, you want to delete something. So before delete, you want to backup that that data, right? Are you able to follow me? Okay.
No, sir, it is not. I'm not getting this. So how to use this while we are inserting something? Suppose a statement, we insert a statement we are using, and where we will write this?
We write in the means PG
given
admin.
A statement, sir. Suppose in the PG admin, what statement will put? As insert.
How to? Okay. Let me,
text. What text we will write? Because I was trying, but it was not working.
There is one post in the discourse.
At first, you have to define the function, and if something event occurs, then you have to call that function, right? So I will define the function for trigger. Like in the last DBMS session, I think I have taken one example, right, of trigger and function. you can watch that live session. We have defined one function, and then that function will return the trigger, and then when we define one trigger, and then we call that particular function using the trigger. Like if suppose insert event is occurring, so that trigger will get execute, and that trigger will call that particular function, right? Yeah, here you can see.
Yeah, you can see here how to apply it. This is the function. Okay, so this is the way. This is the trigger function. So this is how to define the function, and this function will return a trigger. Okay, and what is the if the RD? Okay, you can check it. If any means any confusion arises, then you can ask on the discourse. Otherwise, the concept of the trigger, what is trigger, when to apply trigger, is it clear to you? So you can.
As a concept, it is clear. Yeah, I will try it. Okay.
Yeah. You can try this code on. This is one of the posts from our instructor.
Also, and for conceptual part, there is one tutorial on triggers also. You can watch that tutorial also.
Okay, sir. Thank you. Fine.
Yeah. So trigger is simply a set of statements that is automatically invoke when any event occurs. So event are like the insert, update, or delete. Okay. Any other doubt in the
one thing in some of the text which has been in the lecture, some external language routines or like that with a star function. It was mentioned, but the professor was telling that this is just for the understanding, whether that is required to be reviewed for the quiz 1 or that is not required.
No. Whatever the professor said, these are not important. That is only for the knowing purpose. Thank you.
Okay, that is not part of the syllabus of the quiz 1, right?
Yeah, in explicitly. Yeah.
Okay. Thank you.
Appear, sir, can we proceed with the mock question?
If anyone have any doubt in any mock question, you can ask.
I have doubt in question 5 of graded assessment, week 4.
Graded question assignment.
Week 4, question 5.
Yes, Pradipya.
Okay. Week 4 graded question number
5.
Just one. Okay, is it visible to you? Right.
Yes.
So, can you tell me what is the symbol? This symbol means.
Which one? Oh, many to one.
Not many to one. This is the one to one, and this is also one. So manager and the departments are related by one-to-one relation. Okay.
Okay.
So can you tell me the first this manager one? So in the manager table, what are the attributes?
What manager?
Yeah.
Manager num and manager name.
Okay. In the manager tables, so you can check in the manager tables, which are the manager, this one and this one.
Yeah.
Okay. And the next is the in department tables, what are the content?
Department num and department name.
Department name and the department. Okay. In the managers tables, we can, if we introduce some another tables or the relation, that is the manager names or the department. So we need to make it for the one-to-one, this underlines. So these are the, if we not mention these things, so so it is not a one-to-one relation. So we can make it so this does not means a one-to-one relation, right? So we can text the manager one and the department also D1, right? Similarly, this one. So we use this thing when we try mentions the many-to-many relation.
Okay.
Okay. So this is cancel out. So let's check the next one.
Pradeep, sorry, I missed. Why did we cancel this first one? Managers. What did you say?
One. This one is a not one-to-one relation. So how can you ensure that this is the one-to-one relation? You have to maintain that thing.
Yeah.
So you have to so the one-to-one relation.
Since manager num and department name hasn't underlined, that's why we haven't taken this option.
No. So if we means underscore also, that's also this one is a unique and this are the unique also, right? So whole thing is a unique. So these two we takes the primary key also. So these are unique also, right? MD1 and M1 ends the D1, M1 ends D2. This are the also unique. But you can see M1 is associated with two attribute of the D1. So that is the one-to-many relation. But we have to show the one-to-one relation. So how we can ensure that? Is it clear?
No, not clear. Because I also chose option 1, but that is not the correct option.
Yeah. So for the manager's table, what's the entry? Let's take the entry of the manager. Okay. So this, suppose I only takes the manager number, right? So M1 are the entry, M2 are two entry. Okay.
Yeah, fine.
And the department.
D1.
And the D2.
Yeah.
Okay. And the manager's tables entry, you can tell me what are that entry?
M1.
M1. Okay.
M2.
M2 and the also you have to write.
Yeah. Okay. D1. D1.
Okay. Since something else date is. Okay.
Since yeah.
Yeah. And
then M1.
M1.
D2. Okay. D2. I see.
So you can see this is the one
over here. Yeah, no, this is fine. I mean, I said this particular thing basis what I could understand, but basis this question, why will we say M1 D1 and M1 D2? Why will we say that? If it is a one-to-one relationship, why will, if we have to maintain one-to-one relationship, we will not have this M1 D1 and M1 D2, isn't it?
No, you have to cancel out how this option are eliminated.
Here you have to make sure that the table we are creating are ensuring the one-to-one relationship, right? So if you go for a first option, can we ensure that now here only two tuples we can see, like manually we can do? What if there are thousands of tuples? In that case, can we ensure one-to-one relationship here if we create three tables?
But what I am not able to understand is in the managers table, why will we have the Cartesian product? I mean, basis these three tables, how are you saying that the third table will have a Cartesian product? Is what I'm not able to understand.
No, even if you didn't underline those manager number and department number, so it can take M1 D1, M1 D1, M2 D2, M2 D2, right? So tuples can be repeated, and it will not make sure that our relationship will have one relationship.
If you didn't underline,
if you didn't, because initially it was not underlined, right?
Yeah, it is not underlined, correct?
Yeah. So if you didn't underline, then it can take a duplicate also, right?
I see. Got it. This is what I was not able to understand. Fine.
Yeah.
Thank you. Got it. Yeah.
And if you underline it, then in that case, we have to make sure that it should be one-to-one. By default, like it can be one-to-many also, right? If you underline. But we have to make sure, like in the case of second and third option, you can see B and C, it will be one-to-one relationship, right?
Managers will contain M1, M2, sins, and D1, D2.
Yeah, for every manager associate with one department, right? That is one-to-one. And one manager is associated with one department.
So this ER diagram and this table, these are relational tables. So these are need to be equivalent. So whatever constraint here we apply, it should be reflect here also. Okay.
And you said this was explained in the activity session of week 4, right? We can have a look over there in case we need the detailed understanding, right?
Yes, we have Arup sir has explained one-to-one relationship.
Okay.
All the cardinalities. Please watch that week 4 activity session. Okay, I suggest you to watch that because it is totally dedicated to ER diagram only for 2 hours. Yeah. Okay. Yeah. Any further question? Any next question from Mark or anything?
Question number 16 from Mark.
Question number 16, right?
Yes.
Are you presenting it or shall I?
Yes, sir, you can present.
Okay.
So in this,
yes.
But there was a similar question, I think, in the activity or in some practice assignment in week.
Okay. Yeah.
But
here a designation ID is a foreign key, right?
Right.
And this designation ID is a primary key here. So our query is select star from employee full auto join designation employee dot designation ID equals to this employee dot designation ID equals to designation dot designation ID. Since it is a foreign key, it must have at least one common row from this designation ID of the designation table, because it's taking the reference from this designation table, right? At least one common designation ID must be there. So suppose it is DS1 and it is having DS1, DS2, DS3, right? So it must have at least one. That is the foreign key constant here, right?
Right.
So if employee table has 100 row and designation has 6 row, and if we consider maximum number of rows written by the following query, so we have to consider at least one row here because for the foreign key. So it will have 100. So one common row, that is 1, and remaining is 104, right? That is 104. That is from 99 from this and 5 from this table. So that is 104. So total it will be 105.
So this 99 will be common, right?
No, only one common is there, default DS1, right? So
okay.
Yeah. So total there is 106, right? In total, but there is one common tuple. So we have to subtract that, right? That is 105.
This is in case of full outer join. If it is right outer join.
Okay. So here it is. If it is right outer join, means it will take right table, right? Designation. So right table has 6 rows. So it will return. It can return maximum 6 rows, right? So one common and remaining 5. So total 6. So one common and remaining 5, right? It is 6. So it will have 6 answer, 6 tuples.
The minimum will be 0, right?
No, minimum will not be 0. So minimum will be in the case of right outer join, right?
Right.
In the case of right outer join, if there is common attribute, it still be 6, right?
Sir, minimum will be numbers of which table has the more attribute. That is the minimum.
No, in the case of right outer join,
you asking about right outer join or full outer join is the minimum numbers of full outer join?
Right outer join minimum.
Right outer join. So that is whatever table present in the right side.
Right side.
That is.
So that means 6 minimum and 6 maximum, right?
Yeah.
And similarly for left also.
Left
also. Whichever is present in.
Yeah.
And in case of full outer join, minimum will be
the table which contains the maximum number of tuples.
Yeah. So total will be.
Yeah. Answer need to be matched. The whichever's the less numbers of the attribute should match with the this left. Suppose there is the one departments and the employee. Right?
So it will be of help if we take, for example, if it is a left outer join, then how do we take 100.6.5? If you can just explain that, it would be clear.
If it is left outer join, it is 106. So maximum will be 100, right? Because first, suppose maximum means we will consider only at least one designation ID is there in common. So it will have one common tuple and remaining 99 will be there, right? So total 100 in the case of a left outer join. And if we consider minimum also, and if, so all the 6 designation ID is there in the employee table, say DS1, DS2 till DS6. So it will match with the 6 designation ID since designation ID cannot be repeated, right? So 6. Then the remaining will be 94 rows, right? So still it will be 100 in the case of left outer join.
Okay.
But in the case of full outer join, it will be different, right? What will the minimum in the case of full outer join?
We will compare the tuples.
Consider all the 6 designation IDs there in the designation at column. So minimum will be in the case of full outer join
100.
Yeah, 100, right? So what full outer join it will do? It will first fetch the common tuple, then the remaining unmatched tuple from employee and designation table.
Right.
Yeah. So if we consider all the 6 primary key is there in the designation ID, so that 6 common tuple will be there, and remaining tuple will be 94 from the employee table, because we already covered all the tuples from the designation table, right? It cannot have a duplicate value. It is a primary key, right? It can have only 6 tuples. And the designation ID is not a key, so it can take DS1, 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 then DS2 110 times, then DS3 say 50 times, like this, right? In that case, it will be a 100 tuple, right? 100, yeah. It will be 100, right, for the minimum?
Yeah. So, and suppose the left outer, this left side, the table is employee, and the right side is designation, right? So every tuples of the designation is matched with, so this is the corner case for the minimum. So every tuple should be matched with each other, right? So after that, we compared with whichever have the maximum numbers of tuple, that is the minimum.
And if we flip the tables like designation, right, left outer join employee.
Yeah, it will not affect in the full outer join. So I said whichever has the, in case of the left, so whichever's the present in the left side, so that is the maximum numbers and that is the minimum number also. Piyush sir, can you stop for a minute?
Sorry, I didn't hear you.
Presentation.
Okay, okay. Stop.
Okay, so this is the left table. Suppose this is left table EMP and this one is the department. Okay, so suppose entry is like, we can, this is first we take the simple example, then we generalize it. Okay.
Okay.
So this is the left outer join, and these are the matching, right? If you apply the left join, right?
Right.
So when it will gives the minimum, so if for the left join, if it is matching or not, we already what left join will do, it will returns all the value of this and the matching column of this one.
Right.
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 So it will not affect either is the minimum or the maximum. It will always returns the numbers of tuples present in the left side. Okay.
Okay.
You got it. This thing. So
Yeah,
present.
I got it.
And for the right join.
For the right join, it will return the common and what is in the right table.
Right tables. So it will not affect by whatever's data present in the this side.
Right.
Means the left side. Okay. So can you tell how many numbers of tuples will return?
Two. In this case, two only.
Two. If it will 3, 4, it is 3, 4. Then let's tell what is the numbers of tuple.
2.
Then also 2.
Right.
So it will always returns the numbers of tuples in the right hand side tables, and the for left it's always returns for the left side tables numbers of tuples. So
both
maximum or minimum are the same.
Okay.
Okay. And for the full outer join,
the whole table will come from.
Outer join, this will gives the unmatching row, right? Unmatching tuple will gives the maximum numbers of tuples. So here you can see first it will return here, then returns the matching tuples, then returns the right hand side. Okay.
Right.
So 1, 2, 3, 4. Oh, I think there is the matching. So matching will returns the minimum numbers of tuples. So that is the minimum number. I said the first it will match, then it will returns the numbers of tuples which have the maximum numbers of tuples. So first it will match, then the maximum numbers of tuples. Okay. That will gives the minimum number of means minimum numbers of tuple. Okay, this will gives the minimum numbers of tuple. Shall I repeat? This will give because there you can see the matching numbers of matching.
Here matching are 2, right?
First it will match and then it will give the result.
Yeah. So if 3, 4, 5, 6, then can you tell me what is the minimum numbers of tuples?
Six.
There is 6 because first it will match.
First it will match and then it will give add-on additional.
Yeah, whichever's the maximum numbers of tuples. So in this way we can calculate the minimum numbers of the tuples in the outer join. Okay.
Pradeep, just once more for outer join, please.
Yeah. So what is the condition of the outer join? First you have to, first it will match, then returns the matching tuples, then it will returns from whichever tuples not matched from the right, that it will return, then from the right hand side tuples. That is the basic functionality of the outer join. Okay. So how we will get the minimum numbers of tuples? So suppose this employee has the 4 tuples and this has the 6 tuples. Okay. So how can you find what is the minimum numbers of the tuples in the outer join? Okay. So for the condition, this tuple need to be matched. One of the tuples of every value of the tuples which match with other value of the tuples. Right? That is for the minimum condition. So in this way you can get minimum.
What will be the minimum in this case?
That is 6.
Maximum, sir? Maximum will be?
For the maximum, you have to create the condition for that. How you can get the maximum numbers of tuples. So suppose there is the 6 tuple, the 4 tuples, and this has the 6 tuples. And for the maximum, you have to find this tuple should not match with this tuple. Then you get the maximum number.
Create an example, sir. How to do that?
Okay. So suppose entry is like 2, 1, 2, 3, 4, and here entry of this one is like 5, 6, 7, 8, 9, 10, right? So full outer join, what will do? It will take first match numbers of the columns. So is there any match? This tuple? No.
No.
No, means 0. Then it will return all the tuples from the left side, whichever the tables present in the left side. So that 4. Is 4
and 6.
And this is the 6. Then the total numbers of the tuple is 10. So maximum tuple is 10.
This is maximum. This is minimum. This is minimum.
10 is maximum, right? 6 is minimum.
No. In this case, which is the minimum? Minimum is also 10. Suppose we make a full outer
you
join.
have to create the condition. So if you have given.
No. Sir, employee is a table and department is a table, and the entry is like this: 1, 2, 3, 4, and 5, 6, 7, 8, 9.
Let me tell you. The question is like that. The employee has 4 tuples. Okay. So question is simply like this.
Okay.
It is not given to you. You have to create this condition and you have to test it. So I am telling just the condition, how you can create the condition. For the question is like that, the employee has 4 tuples and so the department has 6 tuples. What is the maximum numbers of tuples in the outer join? And what is the minimum numbers of tuples in the outer join? That is the question. Only this thing is given to you.
Okay.
You have to create the condition. Is it clear to everyone? Hello. I think Apu has asked.
Yes, sir.
Yes, clear. Thank you.
Yeah. Thank you. Next doubt. What is? Any other
Now-
doubt? Yeah.
No, sir. Fine, sir.
Uh,
Session very nice. Sir.
So we have released the mock solution also. I think earlier only we have released. You can go through the solution also. Yeah. Okay. Any other doubt? Any mock question or any other question? Yeah. So for week 1, please go through the revision slide. For week 2, you can go through the live session of like SQL practice live session. And for week 4, you can watch the week 4 activity live session, okay, and all the tutorials. Yeah, so please watch that live session and the tutorials for week 4. It will be very useful.
Please repeat once, sir. Week 2 is live session. Okay.
Now for week 2 and 3, you can watch the SQL practice live session, right?
Okay.
And for week 4, please watch all the tutorials and week 4 activity live session. So there we have discussed all the ER diagram and all the concepts. It will be very useful for you.
Okay. Thank you. Thank you. So nice, sir.
Okay, if there are no any further question, we can wind up this session. Yeah.
Yeah, sir. Fine. It was a very nice session. Revision was very good, sir. So nice.
Okay, well, thank you. Yeah.
Okay. Thank you. Thank you, everyone.
Thank you, everyone. Thank you.
Thank you. Thank you, guys, everybody.
Thank you.
Thank
Good
you,
night.
everyone.
Thank you.